Good morning to Perpetuum mobile. On the channel for the development of the free energy motor. The production of energy out of the nothing. The phenomenological nothing in the free energy. Not the real nothing. Today I want to speak about a certain physical necessity to modify the general relativity theory, or a theory of quantum gravity and quantum cosmological connections between the ever smallest and the smallest and the largest things. We can also say the ever smallest and the ever largest, depending on the singularity. A singularity is a layer of complexity. The imaginary number is the complexity of everything, and one can imagine that if the imaginary number, because it is too complicated for us humans, multiplied with numbers, then it gets less complicated. It means imaginary numbers can be used for the description of superstrings in the Hilbert space. And the quantum cosmological aspect, properties of the universe, can then be understood as imaginary numbers depending on velocities and on different velocities on the cosmological and quantum layer, on the cosmological and quantum layer at once, which then substitutes imaginary numbers or real numbers. It's an adding of real and complex numbers to forces, and so that the imaginary and real numbers are forces, and we get a simple classical mechanics for forces for the ever complicated things which are possible for quantum gravity, as if the school physics in the high school or in the Realschule in Germany, or gymnasium would at this moment then change to a calculation of quantum cosmological questions, although it is only calculated with forces. Okay, what I want to explain now is, imagine that this is the universe. This is the circle square. Everything can be described in this one circle, the square with this circle. Oh, early in the morning again. And here's again this square inside. Oh, I know that. Sorry. It's okay now. No. And I draw it now as Hilbert space again. One can draw it also as a Euclidean space and as Cartesian space. It depends on the question if it is with the basis 10 or it is logarithmized, or if there is a e function that transforms the high numbers to the low numbers. Here for the Hilbert space we have the imaginary numbers. The horizontal lines mean the spaces. This is the vertical line. Vertical line is the force space dimension. We have here also the directions of parity, negative and positive parity, and positive and negative parity. This belongs later to the question if we have a superstring here, a circumference, which is the force, that velocities and positive and negative accelerations in certain parity directions mean a certain length of imaginary and real numbers. Okay, but what I want to explain here is now that let's imagine here's a planet. Here's a planet, and it has now about an energy of 10 to 34 joules, because it's here. Here's 1 joule, here's the lowest, here's 10 to minus 8, 68, and here's 68 joule, 10 to 68 joule, and it is in the near of the middle. This is the middle of the universe. And so we can say we have here the location, and we have the energy state of the planet here. We can, this is the total energy, this is EM squared, so the planet must have, okay, then it's not a planet, sorry. No, it depends a little bit what kind of space transformation we use, but we have the total energy here. It gets more complicated. The total energy is here. This is here the total relativistic energy here. But we can only also use this here as a smaller singularity, and then we use, instead of the relativistic energies, the potential energy and the kinetic energy. Then we have the Hamiltonian, and it's the kinetic energy plus the potential energy, and this is a system where we reduce this whole this universe to a smaller area. Then, for example, we would draw the sun as a system, but the sun in a like this. It depends on the perspective. We could turn it here a little bit, the perspective, and then it would be a right scale. But it depends also, there are transformations, okay? Then we can use these parameters. What I want to explain today is transformation inside the Hilbert space. We stay all the time in the Hilbert space. Okay, I want to take this point here as the sun. I take this point as the sun, and I take this point as the Earth. Okay, in the Hilbert space. Then I have already chosen a certain size here for the Hilbert space. This could be maybe here. This distance is blackout. 1.496 times 10 to 11 meters. And then this whole space cannot be so big. But we can also draw here a picture inside a square. And then this is a singularity. This is singularity. It's a square circle inside the square circle. So, and this is another square circle then here. This beholds the size of the universe, the size of the cosmos. I distinguish cosmos and universe because our three-dimensional or four-dimensional cosmos is one cosmos, and universe I mean also the multiverse, which we reach if we go to the cosmos and then further here on this step. For example, we are here in this universe. This is this line, the total energy. We go to the border of the universe, and then then we go in this direction here. And visit here now the next universe, or here, the cosmos. Out of our perspective, the 1 meter singularity, the parallel cosmos here, the distance here of the meter out of their perspective here of the parallel cosmos is 0 meters out of our perspective. But out of their perspective, our 1 meter here is 0 meter. We say this is our line here because our universe is the whole energy of all universe. While this universe here is very small energy. It is then an atom. It is so as if we would consider an atom. Okay. But out of their perspective, this is also the energy of the whole universe. The alien in a parallel universe would say they are on this line and we are on this line, and we say we are on this line and they are on this line. It belongs also to the questions of superconductivity and hyperstructure forming, where little where the light velocity gets very slow, although the light velocity stays always the same c. Okay, what I want to explain here in this lecture is that both points here. What I wanted to explain is that the Earth curves around the Sun. We can draw it also like this here. Then okay, it works, but it works. Then I have to turn again the coordinate system here. But to turn it around the Sun can also mean this in this direction and then back again. But it is a circle nearly, a little bit elliptic. What I want to explain is that the Newtonian law the time runs again. I can only make 50 minutes. It's like this, and then we get a velocity of this here. This is indirect proportional to this distance. I introduced now a new velocity, and we get very small velocity here at the border of the universe, and a very high velocity here in the center. While another velocity is this here. This is ekin by m0. If we take the flat spare, the gravitational energy of a field of the space by c squared, then we get this energy. This is what I want to explain. This is indirect proportional to the